Our wonderful friend Pete Ludovice is here. Hello, let's welcome Pete.
Wonderful friend.
You're a wonderful friend.
That's Pete. A promotion now. I was the guy living in the cardboard box about 3 hours ago.
So Pete, of course, you want to introduce yourself. Pete's a faculty member at Georgia Tech as well in the
School of Chemical and Biomolecular Engineering.
Excellent.
It's not a conversation starter at parties. We got some people who are like, well, I feel sorry for this gentleman, but it's...
So we've got the mathematician, we've got the chemical engineer.
We've got the lawsuit from the Kennedys.
We've got the genetically...
It's not going to be good.
We've got the genetically modified rock band. Woo! Raise all 9 of your arms. That's 10. Not 9 that you got to.
Okay.
All right, Roman numeral joke. All right, so enough of that.
We've got the conic section here.
So Pete, as I understand, you have a science experiment to show us today.
I do indeed, and I warn people about their eyebrows in the front row.
All right, so shall we go ahead and bring that out?
Let's do it. Okay.
Let's go ahead and
all right, let's do it.
Let the experiment begin.
Since we have no, union folks working here, you're going to have to help me move it out. So let's see what we can do. All right, you might want to tilt it at an angle. Let's tilt it at the other angle.
There.
All right. We got a decent shot there?
Are
we good? Are we good? Maybe you don't want a decent shot. Who could blame you? I can't really.
All right, Pete.
All right.
It's all you.
All right, so what we're going to do today is a bit of a chemistry experiment. It's now called something different. For those of you that are weird and cruise weird websites like I do on the internet, it's now called molecular gastronomy. Basically cooking with chemicals. We've been cooking with chemicals for a long, long time. So weird things like pectin that you use to thicken jellies and jams. Probably your mom or grandmother did that sort of thing before. Actually, extracts from seaweed, like things called carrageenan. You find those in your food products as well. Today we're going to work with something called sodium alginate. And sodium alginate, I actually brought some visual aids, Lou. Sodium alginate is actually derived from seaweed. You can get it from a number of different plant sources. The most common one is seaweed. And again, it is often used as a food thickener because it's a big, long molecule made of sugars. So anything from starch, Lou eats them on a regular basis, and then explains why he's in the can on a regular basis. So sodium alginate is kind of interesting because it has an ionic group, right? So there's an H+ ion on it. Let me see if I get a structure, right? Normally you have this COO sort of minus ion, and you typically have an acid with that. They replace it with a sodium ion. And the interesting thing about sodium is it's a +1. So that means there's one ion in it. And if you take it and mix it with an ion that's got a +2, I've got it here somewhere, calcium chloride, then you can actually get the calcium +2 to connect to 2 different strands. So this is something you can do. The nice thing is you used to have to go to chemical supply houses to get this. Now, because people use it to thicken sauces, they use it to make nice little gel beads. Let's see if I got a picture of that. Did I put a picture of that in there? No, I did not. I made a picture of that, but I didn't put it in there. To put flavoring things in it, kind of looks like caviar. It looks really nice if you give a hoity-toity dinner party. If you put it into calcium chloride, the +2 ion will make the chains stick together, and you can make both beads and strings. So let me do a few of these things. And now we have sort of a worm. And the worm is, okay. Okay, now wait a minute. I did that on Iowa television once. The host actually did eat it. It did not end well. I'm going to leave it with that. Okay, so now I'm going to talk about another molecule that you can buy at your local vitamin shop. It's called EDTA. How many people have seen EDTA on the side panel? So did you read the side panel of the consumer products you buy? So then you have no social life just like I do. So EDTA is something called a chelating agent. It grabs metals. So it'll grab that calcium ion and take it away. I have a theory that if we actually take our little worm, put it in a bunch of EDTA that's dissolved in water, we're going to let that sit for a few minutes. Hopefully it will start to get a little less stable and dissolve. If it doesn't, that means I've timed things incorrectly. I got a 50-50 chance. But the nice thing about EDTA is they put it in consumer products to grab any additional metals. And that's really good because too many metal ions will affect the way your hair gel, your shampoo, even your food behaves. So they put it in there. They used to do it for heavy metal poisoning. Problem with EDTA is it pulls all the ions out of your blood, not just the lead or other heavy metals. So we stopped using it about 50 years ago. Now we use much more subtle chemicals. But if you put it in your bloodstream at a high enough concentration, it will mess up the iron, the manganese, the magnesium. Not really good for you. It will grab the calcium. It grabs it in kind of a neat way, sort of surrounds it, and grabs the metal. And it'll grab the calcium, and people think you should take this at vitamin stores because it takes away the calcium. Calcium plays a role in plaque formation. It's a much more complicated phenomenon than just pulling the calcium out. It can actually be quite dangerous, so I do not recommend this, and we'll hopefully see an example of it tearing apart our calcium ion here. But if we take it and put one of these things in sodium chloride again, then that single ion will replace this. Now we're going to try red. The way I got red and blue? Food coloring. All right, where's my calcium chloride? So we'll make another worm here. I'll grab my worm here, and then hopefully, so it's pretty stable. Again, tastes bad. We put it into sodium chloride, steer that around. All right, let's let that go for a bit. And let me see. Okay, I can't even pick it up. So EDTA has dissolved this, which is probably why you shouldn't be putting it in your bloodstream. And yeah, so I'm already breaking this guy apart. Yeah, so this guy's breaking apart as well, and that's replacing the calcium chloride. But you can buy these on the web, on molecular gastronomy sites, make cute little caviar beads to put flavors in.
Flavor beads.
Just don't take the EDTA pills you can buy at the vitamin shop.
Thank you, Pete. Thank you for that moment of science.